Dear students, I am a faculty of SST Academy of Mathematics as 18 years of experience in mathematics teaching. So today we will be moving to one of the finest and most important concepts in engineering and astronomical physics studies, the concept of trigonometry. Let me introduce what do you mean by trigonometry. Trigonometry. It is a word, it's derived from, it is a word derived from Greek. Tri, it's nothing but 3. Gono, it's nothing but sides. Metry, it's nothing but measurement. So, trigonometry, it's nothing but 3 sides measurement of a right angled triangle. We call it as trigonometry. So where does this word trigonometry is actually originated? So if we go for ancient one, 500 AD, our Indian astronomer by name Aryabhatta, who wrote in his book Aryabhatiyam, that is the word trigonometry. The word trigonometry. So use the word sine. Use the word sine. We call it as ardhajya. We call it as ardhajya. So ardhajya is nothing but half chord. Ardhajya is nothing but half chord. Later it has been shortened as jya. Later it has been shortened as jya, and it has been translated this word into Arabic. It is also it has been resigned as jia. Later on it has been translated to sinus. The word sinus has gone for the word, it is called Latin word sinus. Then this sinus have been shortened, abbreviated by the English professor of astronomy by name Edmund Gunther. He is the man who abbreviated the sinus as short-termed as sine. Short-termed as sine. And all these angles, sine, everything all comes under an acute angle. Comes under, and he went for complement of that, and he called it as cosine. The other complement of the sine is about cosine, sinus. And later on this cosinus have been abbreviated as cos by the mathematician for astronomer Jonas Moore. He is the man from British. He has been abbreviated as cosinus as cos and sinus as sine. This is the word, right? Sinus have been given as Edward Gunter, and cos have been abbreviated by Jonas Moore. So where does we use this trigonometry? So the trigonometry is nothing but the triangular measurement of a right angle triangle. Triangular measurement of a right angle triangle. So all this comes. It have been used in higher engineerings and astronomical physics. Today, you know about NASA or ISRO, everyone to launch the orbiter on the outer space or revolving around the earth, or sending any rockets to interspace or universe. So they use the word trigonometry. The basic concept of that, without that we can't change. The altitude and longitude, everything comes under the word trigonometry. Okay, next we move on to that. The other part of this is trigonometric ratio. Trigonometric ratio. Trigonometric ratio. Trigonometric ratio. The ratios of the sides of a right angle triangle with respect to its angle we call the trigonometric ratio. The ratios of the sides of a right angle triangle with respect to some angles, acute angles, we call the trigonometric ratio. We call it trigonometric ratio. So let me take a right angle triangle. Let me take a right angle triangle. Let me take a right angle triangle. So right angle at B, I'll name it as A, I'll name it as C. So you know very well about the right angle triangle as three sides. The biggest side of a right angle triangle we call it as hypotenuse. Yes, we'll let you write hypotenuse. The biggest side of a right angle triangle. The biggest side of a right angle triangle we call it as hypotenuse. Then we have the other two sides. We are going to give the name for the other two sides and depend on the acute angle. There are two acute angles here. One is angle A, the other one is angle C. Both are acute angles. So I'll take it as first acute angle as A. Now you can notice in that angle A, there is a side which is opposite to angle A. This is what we call as BC. This BC is just opposite to angle A. Hence we take it as, if we define angle A as acute here in this problem, then BC we call it as opposite side. Then we call it as opposite side of BC. Opposite side. Okay. Opposite side. Next, the side which is adjacent to angle A, we call this as adjacent side. We call it as adjacent side. So now this we call as BC as opposite side and AB we call it as adjacent side. It is just the angle, the side which is opposite to the acute given angle, we call it as opposite side, and the other side we call it as adjacent. This is the side adjacent to the angle A. Side which is adjacent to angle A, we call it as adjacent side. The side which is opposite to angle A, we call it as opposite side. And if acute angle is given as C in the question, if this is angle C is an acute angle, so obviously we know that AC is the hypotenuse. The side which is opposite to right angle, we call it as hypotenuse. Hence I write it as hypotenuse. The side which is opposite to angle C, dear students, the side which is opposite to angle C is what? That is AB. Hence we call this as opposite side. Side opposite to opposite side. Then BC. Now what is BC here? Now this BC is adjacent to this angle C, hence we call it as adjacent angle or adjacent side. The side which is adjacent to the angle we call it as adjacent side. The side which is opposite to angle C we call it as opposite side. So these are the three sides of a right angle triangle. Right angle. Without this right angle triangle, you can't find out the word trigonometry. Trigonometry is entirely based only on a right angle triangle. Now, if we take the trigonometric ratios, trigonometric ratios deals only between what? Acute angles. Between acute angles, trigonometric ratio. Trigonometric ratio. Let me draw a triangle. Right angle. It's A, B, C. The angle C is an acute angle. Now we are going to define trigonometric ratios. So there are 6 trigonometric ratios based on these angles. So what is the first ratio? Let me take it as, so Let angle C, I'll take it as sum as theta over here. Angle C, let me name it as theta, some degrees. Let me take it as theta. Now, sine theta. Sine theta. Shortly sine, I can write as sine theta. Now, children, what is AC from this right angle triangle? Yeah, sure. Yes. It is hypotenuse. Shortly, I'll write it as hypotenuse as HYP, abbreviating word. Next, the side, if angle theta is over there, the side opposite is theta is AB, hence I call this as opposite. Shortly, we abbreviate it as OPP for opposite. Next, the side which is adjacent to the theta is BC, hence I call it as adjacent. Shortly, I write as ADJ. Shortly, I write it as ADJ, adjacent side. Sine theta. Sine theta, the ratio, that's nothing but opposite side by hypotenuse, which is nothing but AB by AC. AB by AC. The second one we call it as cos. Cosinus, shortly written as cos theta, which is nothing but adjacent side by hypotenuse. Shortly, I will abbreviate it as ADJ, adjacent side. Hypotenuse I can write as HYP, hypotenuse, which is nothing but, can you tell what is the side adjacent? It's nothing but BC, hence I'll write as BC by the side hypotenuse, I'll call it as AC. BC by AC. The third one is about tangent, tan theta. So tan theta is nothing but, it is the ratio of sin theta by cos theta, or I can call it as opposite side by adjacent side. Opposite side by adjacent side. Hence, opposite side is nothing but AB by BC. By BC. Yes, students, there are 6 trigonometric ratio. The first 3 is very important. If you know the first 3, the next 3 is very easy. And we have that. Just the reciprocal of the first 3 will get the second 3. That is sin theta's reciprocal ratio. We call it as cosecant theta. We call it as cosecant theta. The fourth one, cosecant theta. It's a reciprocal. That means hypotenuse by opposite. Hypotenuse by opposite. I can write it as AC by AB. AC by AB. Next, the reciprocal ratio of cos theta is about secant theta. It's about hypotenuse by adjacent. Hypotenuse nothing but AC by BC. AC by BC. The next one is about, sixth one is cotangent. We call it as cot. Cotangent we call it as cot. It is nothing but adjacent side by opposite. Adjacent side by opposite. What is the adjacent side? BC. Opposite AB. So these are the 6 trigonometric ratios. The entire chapter is based on these 3 concepts are very important. Sin theta, cos theta, tan theta. Sin theta, cos theta, tan theta. Then the other 3 are the reciprocals of this 3 trigonometric function. One is about cosecant theta, secant theta, cot theta. So the first definition of sin theta you should tell us always opposite side by hypotenuse. Cos theta should tell adjacent side by hypotenuse. Tan theta is opposite by adjacent. Opposite by. The other 3, cosecant theta is nothing but hypotenuse by opposite. Secant theta is about hypotenuse by adjacent. And cotangent theta we call it as cot theta. Cot theta is nothing but adjacent by opposite. Okay, students. So if you know this, we can do some problems based on this. Okay, right. Let me go that. Let me take Question number 1. So, in question number 1, in triangle ABC, right angle at B, right angle at B, if AB is equal to 24 centimeter, BC is equal to 7 centimeter, determine number 1 sin A, number 2 cos A, number 3 sin C, number 4 cos C. Okay students, first when you are dealing with trigonometric ratios and identities, entire topic of trigonometry, you want to draw a right angle triangle. So you draw a right angle triangle first. Yes, this is the right angle triangle. Right angle over here. Fine. So first you understand the question properly. So in triangle ABC, right angle at B. Therefore, where is right angle? Here. Therefore, I named as this side as what? Angle as B. The other two sides, whichever you want. One you can take it as A. You can take other one as B as C. So I'll take it as A. I'll take it as C. Now they are asked you to find if AB is equal to 24 centimeter. You know what is AB? AB, this is 24 centimeter. Then BC, it's about 7 centimeter. If AB is equal to 24 centimeter, BC is equal to 7 centimeter, then you want to determine sin A. That means it indicates angle A. This is the acute angle, hence I'll write it as A. Now students, you know that whenever the angle is given, if they are defined, it's an acute angle. If the angle is given, you know that the side which is opposite to that given angle, we call it as opposite. Therefore, from this diagram, we can tell that BC is opposite side. We will abbreviate it as OPP. Next, the adjacent side. The side which is adjacent to the given angle A, we call it as adjacent side, ADJ. Obviously, we know that AC is nothing but what here? One is opposite, the other one adjacent. Yes, the side which is opposite to right angle is nothing but hypotenuse. Hence, I'll take this as hypotenuse. Hypotenuse. Now, we want to determine, without knowing hypotenuse, it's not possible to find sin, cos, sin C, or cos C. That means, first we want to find what is hypotenuse. So we're going to find out the hypotenuse. You might have been learned in your previous classes, previous years. That is Pythagoras theorem. That is what? Pythagoras theorem. What is the Pythagoras theorem? Yes. Pythagoras theorem. Square on any one side. That is, square on the hypotenuse should be equal to sum of the squares on the other two sides, which is nothing but AB square plus BC square. Square on hypotenuse should be equal to sum of the squares on other two sides. Sum of the squares on the other two sides, which is nothing but Pythagoras theorem. Yeah. So what do we get? What is the value of AB? AB is about 24. Hence I write 24 square. What's the value of BC? BC is nothing but 7. Make it as 7 square. So we know that 24 square. What is the value of 24 square? Tell me that. It's around 576. Then 7 square is about 49. So 576 plus 49. You know that very well. It is about 625. So AC square is equal to 625. That means AC is equal to what? Root of 625. We take it as plus or minus here. So the value actually what we take is about positive. Therefore, AC is equal to, we know that students, what is root of 625? Yes, correct. It should be what? 25. Therefore, the value of hypotenuse is what? 25. After finding the hypotenuse, then we can determine and find the values of the given respective angles. Okay. Okay, students, let me go for solving number 1 first question. What is sine A? Sine A. What is the ratio of sine? What is the ratio of sine? It's nothing but opposite side by hypotenuse. Can you define what is sine A here? If this is the angle A, the opposite side is what? BC. Hypotenuse AC. Therefore, I will write it as BC by AC. What is the value of BC? BC is about 7. Hypotenuse value is 25. Second question. Cos A. Yes. Cos A. What is the value of cos A? Tell me, students. Adjacent side by hypotenuse. Adjacent side is what? AB by AC. What is AB? It's 24 by 25. Okay, this is finished. Next, we are going to determine the angle C. Acute angle. Yes. We'll draw one more figure here. That same figure. A, B, C, angle C. Then AB is about 24, BC is nothing but 7, hypotenuse is nothing but 25. The side opposite to angle C, this will be called AB as opposite here, OPP. The side which is adjacent to angle C, we call it as adjacent side. And this one AC, we call it, this is side opposite to right angle, we call it as hypotenuse. So we want to find sine C. You want to find sine C. Problem number 3. What is sine theta? The ratio of sine theta is what? Opposite side by hypotenuse. What is opposite? Here it is from the given figure, we can determine it as AB by AC. What is AB? It's about 24 by 25. Problem number 4. We are going to find the value of cos C. Yes, students, what is the ratio of cos? It's nothing but adjacent side by hypotenuse. So adjacent side here is about what? BC. BC by hypotenuse is about AC. So what is the value of BC here? It's about 7. I'll write as 7. The value of hypotenuse is about 25. So that comes to an end of what? The first problem. First problem is about sine A. The value of sine A is 7 by 25. The value of cos A is 24 by 25. And the value of sine C is 24 by 25. And the value of cos A is 7 by 25. Thank you, students.